Today, I'm going to walk you through the electrical system that we installed in our RV almost 3 years ago when we started living full-time in the RV. When we bought our travel trailer almost 3 years ago, we knew that we were going to have to make some upgrades to the electrical system so that it was more suitable for what we wanted to do. Our trailer, like many, came with a 12-volt battery and no inverter, which was going to be really limiting if we wanted to use the trailer anywhere where we didn't have power readily available. So from the outset, we began to design a system that was going to help us do what we wanted to do. Now, I'm going to walk you through that system today, but just know that your needs and your requirements may be very different to ours. In our case, we came up with a number of requirements and constraints that would help us to design the perfect system for us. The first requirement we had was finding a system or building a system that was going to allow us to camp off-grid for up to 2 weeks at a time. Second, we wanted to be able to, during that time, use just general everyday appliances within the RV. This is things like our laptops, our phones, the lights, the water pump, generally most of the 12-volt appliances and low-power appliances we kind of wanted to be able to use as much as we needed to during that time off-grid. Third, we also wanted to be able to use some of the higher power appliances, things like our Instant Pot and the microwave. But we were quite okay with having that so we didn't need to be able to run them, or didn't need the power to be able to run them all the time. For example, running a microwave for a few minutes or an Instant Pot once or twice during the week is very different from running the AC 8 hours a day, all day, every day. That was something that we weren't trying to achieve. Our final requirement was that we didn't want a generator. We didn't want the noise and the maintenance and the weight that a generator was going to bring, so we were looking for a way to recharge our batteries either using the truck or even better with solar power. As for constraints, our number one priority was safety. We wanted something that was going to be really safe, and we were okay spending a little bit more money to get good quality components that we really believed were going to keep us safe. Second was space and weight. We're here in a 25-foot trailer and we don't have a lot of space, and importantly, we don't have a lot of cargo capacity. So some big heavy batteries were going to cause us a real problem, especially putting them on the tongue because we tow with an F-150 half-ton truck. So something that was going to be a little bit lighter weight was going to be something important for us, and that's something that we considered really early on at the design stage. We also wanted a really low maintenance system. We began RV life because we wanted to get out there and explore, not because we wanted to be stuck in the RV doing maintenance and keeping things running all the time, topping up batteries. That wasn't what it was about for us. And on a similar note, we also wanted a very simple system. We didn't want something where we had to go outside to turn on an inverter or start a generator or something like that. And finally, let's talk about cost. Of course, we don't want to spend more money than we have to have the system that we want, but at the same time, those other things we've already mentioned were higher priority for us. We knew that by designing the system ourselves, we were going to save a lot of money, and having a system like this was really going to help us get off-grid and out of the campgrounds, again, saving more money. So for us, we were okay spending a little bit more money to get really high quality components and a really good system. Oh, and by the way, before we get stuck in here, let me just take a moment to touch on last week's video, our Smart RV tour. If you haven't seen that yet, go and check it out because we've had a lot of great comments, emails and messages from people asking about more information about what they saw in that video and how we did some of that stuff. Don't worry, we're going to have some more videos and blog posts coming with more detail about our Smart RV. Once we decided on our requirements, we began the design process, and early on, one of the big decisions we had to make is where were we going to put everything? In a lot of RVs, people decide to put things in a storage bay. On our 25-foot RV, we only have a single front storage bay, and we already had plans to use that space to put things like our skis and our snowboard, and we didn't really have space in there to put batteries and an inverter and everything else. So we decided to take a little bit of a different approach and install everything under our bed. While we were designing our electrical system, we did some calculations to work out how much energy, in other words, how many batteries, we thought we were going to need. And we came to an answer of 200 to 400 amp hours of usable capacity. We looked at all the different options for doing that, and in the end, we decided that the best solution for us to achieve that, given the constraints, in particular the space and weight, was these lithium batteries. And these 3 Battle-born batteries are at the heart of our system. I'm really pleased we went with lithium because there are several big advantages over lead-acid batteries. The lithium batteries are much lighter and much smaller than lead-acid batteries, even than AGMs, and given the constraints that we were working within, that was a big deciding factor for us. Another big thing that we liked about these is they don't vent gas at all, so they're really safe to be installed under the bed, and Battle-born do some really rigorous testing on these batteries, which again, given they're under the bed, was a big factor for us. As we were designing our system, we did consider doing a completely DIY lithium system using lithium battery cells that you can buy online, and you can wire up with a custom battery management system, some relays and switches and things, and make your own system. In the end, I'm really glad we decided to go with the Battle-born batteries. These have an integrated BMS, which means they're really simple to install. There's not lots of other components that you have to add to keep them safe and to keep everything else safe, and it just makes for a really easy installation. We've had these running now for, like I say, almost 3 years, and they have just been so uneventful, really. Nothing has happened. They've just kept on doing their thing, and I'm really happy with them. We decided to wire all this up with 4-aught wire, which is really heavy gauge wire. It's maybe like, I don't know, half an inch thick. And we did that because we wanted to make sure that everything was really well built. And honestly, it's kind of over-engineered in that regard, but I don't mind, because I know that the resistance is really low. I know that the wires are never going to cause us any problems. They're never going to get hot, even when we're running these things at full capacity. We secured these under the bed on this custom platform that we made. We took out the shelf that used to be in here. We still have drawers underneath, so these are only in the upper half of this area. But we installed a new plywood sheet across here, and then the batteries are strapped down onto that plywood with these straps across here. And this thing, no matter where we've taken the RV, and we've taken it to some pretty off-road places, these haven't moved at all. These have been rock solid in here, and I'm really happy with that. The batteries themselves are a drop-in replacement for 12-volt lead-acid batteries, but there are a few things that it's generally recommended that you do when you install lithium batteries. The first is that the lithium batteries have a very flat voltage profile. So unlike lead-acid batteries where you can measure the voltage to see how full or not full the battery is, that doesn't really work very well on lithium batteries. And instead, it's recommended you use what's called a shunt. And you can think of a shunt a little bit like a flow meter. It measures the electricity, the current going in and out of the battery, and by keeping a track of that, it will then know how full your batteries are. We used the Victron BMV702, which is this Bluetooth module down here, connected to a shunt on the negative terminal of the battery. Another thing we added was the temperature sensor linked to the BMV702. We didn't need to add the temperature sensor. We knew that it wasn't really going to get that hot or that cold under the bed, but we did it because we wanted to keep an eye on things. And as you know from our Smart RV Tour video, we monitor everything and capture all this data. And I can tell you, these batteries have never got that hot or that cold. And in fact, when they do get warm, it's actually because of some of the other components under here and not because of the batteries themselves. If you're interested about some of the specifics of exactly which parts and things we used, be sure to check out our blog post series all about this RV electrical upgrade, where we've got a full parts list and information about exactly how we installed everything you're going to see in this video today. The Victron BMV702 battery monitor connects to our phones with Bluetooth, so we can really easily connect to it and see how charged our batteries are, or how much power is going in or out of them. But we very rarely do that. And that's because we also installed the Victron CCGX. Now this relies on having something like the BMV702, at least something with a shunt, in the system in order to work. But once you have this installed, you have a lot more information available. And for us, the big thing here was that this interacts with our home automation system, allowing us to get all of the data about our electrical system from here and put it into the home automation system, where not only can we check on it on our phones or on our laptops, wherever we are in the world, but we can also use it for automations, such as the ones we talked about last time, where we automatically turn our fridge or other appliances on or off, depending on how much solar we've got coming in and how charged our batteries are. So I've talked about the batteries and a couple of little components here, but let's look at the other wiring that's under here that really makes all this stuff work. As you can see, we installed the 3 batteries over here on one side of the compartment and kept the center section for all of the wiring and the interconnects. If we start on the positive side here, you can see we have the batteries running in parallel, these come down to this switch. This switch here is our master battery disconnect switch, and if I turn this one off, everything here is turned off entirely. These batteries are completely disconnected from the entire system. We chose to use 3 different disconnect switches, and you don't have to. That was a conscious decision that we made to give us very fine-grained control to be able to turn individual items on and off. If we follow from here onwards, you can see that we reach this fuse. This is a catastrophic fuse designed to protect the system in case something goes catastrophically wrong. For our size of system, given the number of batteries, the way we intend to use them, and the wiring that we have in here, we've installed a 400 amp catastrophic fuse. For many of these components, we used Blue Sea Systems. They tend to be a marine provider. They do a lot of things for boats, but they're really good quality components, and although they cost a little bit more, we were really happy with the quality of these. Again, there are links in the description below and in our blog post to many of these products, so do check those out. From here, on the positive side, we come round to this, and under this plastic cover is our positive bus bar. This is essentially a giant junction block, I guess, for all of the different positive things in here, and you can just think of it as just a splitter. It splits the positive off to all the different things that need positive. One of those comes over here to another switch, and this is going to our inverter. So the inverter under here is what turns our 12 volts from the batteries into 120 volts AC that will power all of the outlets and the high voltage appliances in the RV. And we'll talk more about that in a minute. Also coming off here, you can see a red cable going to another switch. This switch is now essentially the disconnect for most of the things in the RV. So if you turned this one off, things under the bed would continue to still operate, which is useful if you want, for example, the battery monitor to keep running, or you want to keep the inverter operating, but we can still use that to kill power to everything else in the RV. Our trailer came with a battery disconnect switch, which is up in the front storage bay, and that does still operate, but we decided it was worth installing a second one near all of this stuff so that if something went wrong, you could very quickly get to this switch and turn things off. If you look at the negative side of the batteries, this is the wire coming from the most negative side, the diagonally opposite corner of these 3 batteries. And this goes down into the shunt. This is the section that you can see here, and is connected around to the Victron BMV 702 that I described earlier, and is essentially the flow meter for how much energy is going into and out of our batteries. On the other side of the shunt, we go into a bus bar, and this is what the positive bus bar looks like underneath, but the negative one is grounded, so you don't need a cover on there because there's not any danger of anything going wrong if something touches it, as you can see. The negative bus bar works a lot like the positive bus bar in that it just distributes the negative, or ground in our case, off around the different things. So for example, you can see here, we have the thick 4-aught cable again going off to the inverter to provide the negative side of the 12 volt DC input. We also have another wire here that goes off to the case of the inverter as well. Now, although I've talked about these as providing 12 volt DC to the inverter, our inverter is actually an inverter charger, which means that it also charges the batteries as well as takes power out of the batteries. So sometimes the electricity is running from the batteries to the inverter when it's turning 12 volts DC into 120 volts AC, but when the batteries are being charged by the charger, so for example if we're plugged into shore power, then energy is actually running from the inverter, being converted in here, coming back through these wires and into the batteries. Some of the other components that you see under here are fairly specific to what we've installed. So for example, this component here is our Red Arc DC to DC charger. This is what we use to charge from the truck, and it takes a big connector on the front of the trailer to bring power in, and then is a dedicated charger for charging our lithium batteries. It's a completely sealed unit, and it's filled with resin, so it's completely waterproof. But one of the things we found early on is it tends to get pretty warm, so we have this fan on top of it. The fan will speed up and slow down depending on the temperature of this underneath. And I can tell it's cold, right? It's very cold right now. The fan never actually turns off, it just slows down, but it's almost completely silent and uses so little power, we just don't worry about that. When this is charging, it does tend to get a little warm, and this fan really helps out and helps to keep it cooler. In general under here, we've tried to use red cables for the positive side of things and black cables for the negative or the ground side of things. We didn't always have enough of the red cables, so there's a few times when you can see, like over here, we've got a switch on the positive side, but we've got 2 cables coming out that are black. In this case, on these wires, we've used some red heat shrink just on the ends, just so it's clear that these are positive wires. One of these wires here comes up to a breaker, and then across here to this DC fuse block. We installed this because we found we had a number of kind of 12-volt small things that were running that needed power. For example, the Victron BMV and the Victron CCGX. We have our booster for the TPMS under here. We also used to have the Intel NUC and several other components from our home automation system installed under here, although we've since moved those to other places, which is why this side of the DC fuse block is pretty empty now. Nonetheless, this is still a useful place to connect all of those devices. Underneath the fuse block, you can see a bundle of wires disappearing into the floor. These are all the wires that connect everything that you see under here to what's going on in the rest of the RV. So for example, we have our main DC negative wire, we've got the main DC positive wire, we've got the AC wires going to the inverter charger, we have the solar wires that we'll talk more about in a minute, and we also have a couple of wires under here that are for our red arc DC to DC charger connected to a plug that we keep on the tongue. And the red arc also has a built-in MPPT charger, so we've also got a connector on the tongue to allow us to plug in a portable solar panel, and so there's a wire coming in there for that as well. The things going into the red arc, we actually run through a couple of fuses. If I did this again, I'd probably use red arc's own fuse kit just because it's smaller than these, but we decided to go with these and they work fine. Here on the back wall, you can see our Victron 150 Smart Solar solar charge controller, and either side of it we have a couple of DC breakers. If you notice, the one over on this side, which is what connects this off to the batteries, is currently turned off. And that's because our solar charge controller is turned off. If you've seen some of our recent videos, you will know that we've recently had the roof replaced on our RV, and all of our solar panels were on the roof, and we haven't yet reinstalled them. So for now, the Smart Solar solar charge controller isn't doing anything. We did choose to install a breaker on either side. Some people don't do this. I felt it was better and safer that way. It also makes it far easier for maintenance. If we need to disconnect one side of the controller or the other, it's really easy to trip one of these breakers. In terms of the solar that we did have on the roof before we had the roof replaced, we had 600 watts of Renogy solar panels up on the roof. When we hit the road, first of all, we had 0 solar. That was never our long-term plan. We always intended to install solar on the roof, but we didn't know how much solar exactly we were going to need. So we started off with nothing and figured we'll just learn on the road. Pretty soon we realized we needed some solar, and actually very soon after we hit the road, we bought a 100 watt solar panel, just a little portable one that we plugged into our DC to DC charger, the red arc charger that you saw earlier. And that was okay, but it still really didn't get us that much off-grid capability. So about 4 months or so after hitting the road, we added 400 watts of solar onto the roof. And we did so in we used series parallel. So we had 2 strings, each containing 2 panels in series. So 2 parallel strings, each one with 2 panels in series. This allowed us to reuse the existing wiring that came on the trailer. So although our RV didn't have any solar on the roof, it did have the combiner box, and it did have some wiring running from the roof down to that electrical bay at the front that we talked about earlier. We did decide to upgrade the combiner box to an AM solar combiner box that has some nice bus bars and is easy to work with inside. But we wanted to be able to reuse the existing wiring because it's in the front cap of the trailer and quite hard to get to. So the wiring that we reused comes in from over here and connects into the solar terminals on the solar charge controller. Right now, you'll see this DC breaker is off because, like I say, the panels aren't there right now. After that initial 400 watts, that worked well for a few months, but we soon decided we wanted a little bit more power. So we added another 2 panels, bringing our total to 600 watts. This worked really well for us, and honestly, we ran like that for about a year before adding a little bit more capacity in the form of a slightly larger portable ground deploy panel. The solar in here in general has been working really well. This solar charge controller links in with the Victron CCGX that we talked about earlier. And if you're interested in learning more about our solar setup, exactly why we installed what we did, then be sure to check out our RV Solar Upgrade blog post series. We'll leave a link in the description below to that. And that details exactly which panels and brackets and wiring and breakers and fuses and everything that we use in our setup. So the last big thing under the bed is our Victron MultiPlus 12-3000. It is a 3000, which might make you think it's a 3000 watt inverter. It's technically not. It's technically a 2400 watt inverter and is 3000 volt amps. The difference there is due to something called the power factor, which for the most part, don't worry about too much, just know that this is a 2400 watt inverter. In practical terms, that means that this inverter can run anything in our RV. We used to run the AC without a soft start. We did later install one just to be a bit kinder to the inverter. But yeah, it will even run our AC on this RV without a soft start. It will run the microwave, the Instant Pot, and all of those things completely from battery power. Now, obviously, when you run those things, it drains the batteries pretty quick, so we do have to be mindful about that. But this is a pretty powerful inverter, and we really like it. The inverter under here is one of the things that tends to produce the most heat. The solar charge controller does as well, but this thing, if it's running, this really puts out some serious heat. So you may notice that we've installed these vents, one at the front and one up here on the side. And that's because the Multiplus has a built-in fan that pulls air in from the bottom and out through the sides. And this is a good example of where we spent a long time really trying to design this system to work well. We knew that we had to pull in fresh air at the bottom and take hot air out at the top. So we could have, in theory, put it on either side of the bed and had this side vent. But with the layout of our RV, there's actually a heat register from the furnace in the floor over on that side of the RV, which is why we chose to put the inverter over here so that the vent at the front wasn't just pulling in hot air from the furnace and not doing a very good job of keeping this cool. As I mentioned earlier, the Victron Multiplus is a hybrid inverter charger. So a couple of things to touch on here. The first is the hybrid nature of this. What this means is it can augment the shore power with some extra power from the batteries if necessary to give you the power you need for running things in your RV. So a good example of this might be if you want to go and hook up to a friend's just like regular 15 amp outlet at their house, or you're at a campground like we've been at where the power isn't very reliable and you can't really pull much more than 15 amps. You can set an input current limit on here to say don't pull more than a certain amount of current from the shore power. So what happens if you're trying to power something and you need more power than that? Well, in that situation, it will then pull the extra power it needs from the batteries to augment the shore power and give you that extra. We've used this a number of times in RV parks where the power's been a bit flaky, and even though we should have been able to pull 30 amps, we see that voltage sagging down as we pull more and more, and we don't want that low voltage. Our EMS that we'll talk about in a minute will cut us off anyway. So that way we can set a shore power current limit on here of, let's say, 10 or maybe 12 amps to make sure we don't pull too much power. It'll take the extra that it needs to from the batteries. Well, eventually that will drain the batteries, but what we find is that most of the time we don't pull a lot of power for a long time sustained. It tends to be in short bursts, like running the microwave or running the Instant Pot or the electric kettle. And once that load has disappeared, this will kick back in then as a charger to start charging the batteries. For me, this has been an absolutely killer feature. I don't think when we first installed it, I really appreciated how much use we would get out of that. But it's just, again, really added to that kind of simplicity function of this. We don't think about it, it just takes care of us. It works really well. So let's talk about the charger. Our RV obviously came with a charger to keep the existing 12-volt battery charged when we plug into shore power. This takes over the role of the charger and can charge the batteries up to 120 amps. Given that we have 300 amp hours of batteries, that means if those batteries were completely dead, this would take about 2.5 hours to charge our batteries fully. Given how much power it can pull back out of the batteries, if we were running this at full pelt and really like working the batteries hard, the batteries could drain in as little as an hour and a half or so. It wouldn't take too long. So it's a pretty powerful inverter. 3 batteries is about the minimum that you could use for this size of inverter. Otherwise, you're trying to pull too much current from each one of these batteries, and you will trip the BMS in the batteries, and you won't be getting full use out of your inverter. And that's the reason that we decided to go with 300 amp hours of the Battle-Born batteries. Could we have got 400 in? Maybe. It would have been a real squeeze in this space under here. And honestly, we haven't found ourselves needing that extra 100 amp hours of capacity. So in hindsight, saving the money was a good decision. These 2 orange wires here coming out of the inverter are the AC 120 volt AC wires. These go back around here and through the hole that we saw earlier, and these are carrying, like I say, the 120 volt AC. One of these wires is coming from the shore power plug on the side of the RV, and the other is going to the AC distribution panel. So when we've got shore power coming in, it can kind of pass through, maybe with a bit of hybrid power assisting if necessary, and goes back to the AC distribution panel. But if we've got no shore power, all of that power is coming from here. These two wires were some of the trickiest wires to run. We had to run them out through that hole and then underneath the RV, kind of along the side of the frame, and then back up to the AC distribution panel. Now I said that one of these wires is going to the shore power plug on the side of the RV, and that's true, but we did install something else between here and the shore power plug. Those two AC wires that we saw earlier come up over here. This is the power center in our RV, and it originally came with this. There's two big things going on here. First of all, at the bottom we have this vented section, and that's where the converter charger used to be installed. Because we now have the Victron Multiplus that works as a charger, we no longer needed this and we ripped it out completely. We then used the space behind here to install an EMS, an electrical monitoring system. The EMS that we installed, we'll put a link to that in the description below. That sits in here, and it basically sits as a protector between the shore power coming in and everything else inside the RV. You can think of it a bit like a glorified surge protector. Its job is to protect everything in the RV from any bad power that you might have. So what does bad power mean? Well, obviously things like a high voltage surge or anything like that, it would stop. But it's also looking for other conditions as well. And one of those is low voltage. Low voltage is something that many people don't even think about, and many people are oblivious to it when it's happening. And that 120 volts AC that we talk about can sag down to 115, 110, 105. We've even seen it below 100 volts at times. So what's the problem? Well, many of your devices will carry on working even when the voltage gets below 100 volts, but they will work in a severely degraded state, usually shortening the life of that component pretty significantly. Especially on high power things like air conditioning units, that can be a real problem. The EMS that we installed behind here has this little display panel, and that allows us to see exactly what's going on. And it also has a toggle on it, so that if we're in an area where we know the power's not great, but we really, really need to run the shore power, we can switch it into bypass mode, and that will disable the protection of the EMS, allowing us to, say, charge our batteries, but we can turn it back into normal use when we're ready to be protected again. This is another of those components that I would really urge you to think about installing, either a hardwired version like this, or Progressive Industries, who make this one, also make a kind of inline one that you can connect to the plug in the RV park. We prefer the hardwired one because it's one less thing to think about and one less thing to grow legs and walk away in an RV park. So that's been working really well for us. At the top here we have our fuse panel. We have the AC breakers here and we have the DC fuses over here. The DC fuses is where the wires, the 12 volt wires from under the bed are coming in to provide 12 volts to everything in the RV. Our lights, our appliances, our water pump, our TV and everything else. Over here on the left hand side you can see all the breakers to do things like our air conditioning, our water heater, our microwave, etc. We did actually make a change to this, and that change was to add two more breakers, two more 15 amp breakers. We haven't changed the master breaker, so the master breaker is still a 30 amp breaker, and that's important because this whole unit is only rated to 30 amps, so we can't change that. Plus the wiring and things are all rated to that as well. But we did add these two new breakers, two new 15 amp breakers at the bottom, and we did that to power these two outlets. All of the outlets in our RV were all on a single 15 amp circuit, which basically meant that anything you could plug into the wall, you could never exceed a total power draw or current draw of more than 15 amps at any point, otherwise you'd trip that breaker. So for example, if we wanted to have the electric kettle on, we couldn't also plug in the Instant Pot, even if we did so in two totally different outlets, because they all shared a common breaker. Going into winter, we knew that was going to be a problem. We had a portable electric heater that we wanted to be able to plug in, we had the electric kettle, we had the Instant Pot, we had the air fryer lid, and we really wanted to make sure that we weren't going to trip this breaker all the time by forgetting and plugging two things in, or just not having enough outlets. So I installed not one, but two more outlets, two more double outlets, each on their own 15 amp breaker. So this one here is completely separate to this one here, and both of these are separate from all the other existing outlets in the RV. Now again, we still can't exceed 30, but we could, for example, plug 10 amps into here, 10 amps into here, and 10 amps into another one inside the RV. This has actually worked really well this winter for us, and we tend to use this not just for the portable electric heater, but we tend to plug in the Instant Pot down here quite a lot, so it's on the floor and out of the way, and we still have the outlet in the kitchen to plug in the kettle if we want to. We're standing here at the front of the trailer, and the bed is just behind this wall, so the inverter and the batteries and everything that we were looking at just a few moments ago are back just a few feet behind here. Now, our RV, like many when we bought it, had the 12-volt battery situated here on the tongue. That was done because it was a lead-acid battery, it needed somewhere to vent, it's heavy, so it sits outside here on in a box on the tongue. When we installed our Battle-Born lithium batteries, we obviously didn't need that battery on the tongue anymore, and we were able to remove it, which also helped reduce the tongue weight. Yes, we'd added some more stuff, but it was a little bit further back inside. In its place, we installed this little box, this storage box. This is just I think it's about a 15-gallon storage tote that we picked up in Walmart, but works really well in this situation. It's screwed down to the existing battery rails, and we use it for storing things like our sewer hose connectors and pieces of kind of outdoor equipment like that we don't need to keep inside in a storage compartment. Also here on the tongue, kind of hidden away behind the bikes, we have an Andersen SB50 connector, and that's what goes inside and connects to the RedArc DC to DC charger on the MPPT input side. That's a lot of letters, so let me make it simple. This is where we can plug in a portable solar panel. It goes to a charger inside, so the panel that we use outside that we made ourselves, if you want to see how we did that, check out our blog post about our DIY portable solar panel. We made that from two 100-watt Renogy panels, the exact same ones that we had on the roof, and we didn't then need a charge controller outside because it was the one inside that was doing the work for those panels. When we bought our RV, it was, like many others, marketed as being solar ready. But what does that really mean? Well, I'm pretty sure it varies by manufacturer and by trailer, but in our case, it meant two things. First, that it had a combiner box on the roof, so you could put your own solar panels on the roof. And second, it came with a port on the side, so you could plug in a portable panel. So if it came with a port on the side, why did we need to add our own as well? Well, the port on the side is just a simple SAE connector that was wired directly back to the batteries. And actually, we were able to use that when we first started. When we bought the 100-watt portable Renogy panel, we rewired behind this outlet here, this port, and actually sent those wires back under the bed to the DC to DC RedArc charger that we saw earlier. And that worked great. We were able to buy a slightly cheaper portable panel because it didn't have the built-in charge controller, and instead make use of the one that we had under the bed. But there were a couple of issues with that. The first is the wiring that's back behind here is pretty thin, and you've got to be careful about how much power you actually put through there. And so we didn't really want to put too many ground deploy panels out. The second was that because of the way this is wired, we had to use like a series of adapters and things to go from the MC4 connectors on the portable panel to the reversed polarity SAE that ours happened to come with. The net effect was a really big long adapter sticking out of there, and someone, possibly me, one day knocked that pretty badly walking past the trailer and bent a load of the pins in there. And I was able to like repair it and get it working again okay. But I realized it was only a matter of time before that happened again. It was a very kind of precarious setup over here. So instead, we decided to install this Andersen SB50 connector here on the tongue. It's a much more robust connector, and we were able to put in some thicker wires going back under the bed. This is now the connector that we use for our DIY 200-watt portable solar panel, and we could even put more than that through there. We've used nice thick wires going back under the bed. And because it's going into a good MPPT charger, that works really well. Our RV, like any other travel trailer, came with the regular 7-pin connector that you connect to the back of the tow vehicle to provide power for the lights and indicators and things like that. It also, in theory, does provide some power to charge the batteries, but really not a lot. And given the relatively large battery pack that we installed inside, we knew this wasn't going to do a great job of charging our batteries. And that's why we installed that RedArc DC to DC charger. That charger is capable of pulling up to 40 amps from the tow vehicle to charge the batteries with. And that's been really, really useful. It's equivalent to over 500 watts of solar panels up on the roof of our RV, working at full power whenever we're towing. To get power from the tow vehicle to the trailer, we installed another connector. We installed this giant Andersen connector. This is far larger than the one we have for the portable solar panel, and this is what we plug into the back of the tow vehicle whenever we're towing, in addition to the 7-pin one as well. And through this, like I say, we can pull up to about 40 amps of power. The connector is way oversized for that. It didn't need to be anything like this big, but I did it for 2 reasons. One, it means I could reuse that connector on the back of the truck for something using more power than this in future. I did use really heavy gauge wire on the tow vehicle. Second, just having that bigger plug makes it far easier to plug into the truck and pull back out again when you're hooking up and disconnecting the truck. This red arc DC to DC charger has been one of my favorite parts of the system. It works really well and gives us a huge boost in power whenever we're towing. We can charge the batteries from 0 to full in about 7 hours of driving, assuming that we're not using power inside the RV for anything else. And usually we do now use power inside the RV for something else. So when we're towing now, we can turn off the propane, we can turn on the inverter, and then we can run our fridge on AC power. And this is great because it means we've got the propane off, which is much safer, but all the power for the fridge is then coming from the truck, meaning that everything inside our fridge stays nice and cold, but we're nice and safe at the same time. The nice thing about using the red arc DC to DC charger in this way is that it has 2 inputs, but the total output from it can never be more than 40 amps. So you couldn't, for example, pull 40 amps from the truck and plug in a portable solar panel and expect that to add to the 40 amps you're already getting. Instead, it'll take what it can from the solar panel and kind of take the remainder from the truck. But that's all right for us, because if the portable solar panel is out and we're driving down the road, something has gone very wrong. So in this setup, it works really well. Here on the back of the truck, you can see where those connections go. That's the connection for our standard 7-pin. And then down here is where I installed the connector for the Andersen connector. It gets pretty dirty in there, even with this cover on there, but I'm not too concerned because those Andersen connectors are self-cleaning. So as you put them in and out, they kind of wipe out any dirt or debris that might be in there, and they work really, really well. We've done some pretty good off-roading, and even when there's been a lot of sand and dirt in here, they clean out really quickly. The wires from here are pretty heavy gauge wire, far more than is necessary for just 40 amps. The negative side is just a chassis return, which on the truck here is fine. And then the positive side runs down the frame rail and up into the engine bay. If you are interested in installing a DC to DC charger like we use, just make sure that your tow vehicle alternator is able to handle that load. We did some testing, and the alternator in here is a 210 amp alternator, so we had no concerns, and in a few years of full timing, using this all the time on every drive, we've never had any problems. The way we wired it in was pretty straightforward. We connected onto the positive side of the battery, which is in turn fed by the alternator. We have a fuse in here running round, and that goes into a solenoid over here. All of these components are rated to far more than 40 amps. I think this is like a 200 amp solenoid or something, and that is simply so that I've got more capability in future if I ever need it. The fuse is the limiting factor. I think it's a 125 amp fuse, which is correct for the size of wiring that we've used in here. The reason I installed a solenoid is so that this wire on the output side of the solenoid is only hot. In other words, there's only actually electricity flowing when the engine is on. So this solenoid is connected to one of the ignition controlled fuses under here, so that when I turn the engine on, this solenoid clicks on and provides power to the back. So right now, if you try to plug something in at the back, it wouldn't do anything. Once you turn the engine on, it would. And the reason we did that is so that when we stop the truck, the trailer isn't still pulling all that power and discharging the batteries. There's a number of ways to do that. We've got upfitter switches in the truck that we installed, and I did think about wiring it into those. But in the end, I just decided this was the simplest option, and this would just ensure that we had power whenever we're driving. We would never forget to switch something on. And more importantly, we would never forget to switch something off and find ourselves with a dead battery on the truck. I really hope you've enjoyed this video tour of our RV electrical system. This is a system that we designed to meet our needs, and when we installed it back in 2018 and 2019, we did so based on what we thought we were going to need. Having now lived with it for almost 3 years, we've been delighted with how well it has worked. It's just sat there behind the scenes doing its thing, and we haven't had to worry about it, which is exactly what we wanted. I really hope this has given you some ideas for maybe creating your own system or maybe an upgrade on your own RV. If it has, and you want to learn more about the exact way that we set it up, the components we used, how we wired it all up, and the tools and everything else, then be sure to check out the blog post series on our website. We'll leave a link in the description below to our RV electrical series, and we have links to everything in there, as well as loads of detail on exactly why and how we installed this system. So thanks for watching, and if you haven't done so already, then be sure to subscribe, and we will see you in the next video. So let me show you what is hiding under our bed. That was horrible.
Do you have bodies hiding under the bed?
Shh. We wanted to use that space, and more importantly, we wanted to install an EMS, an electrical monitoring system. Yeah, why not?